Alright, actually record, because I forgot to record in my lecture earlier today. Alright, so how's everyone doing? Anyone working the project? I know I asked that in Discord, but looks like mostly no, which is maybe expected, but make sure you work on that as soon as you can, because it's going to be a lot to do. Is that a yes, you worked on the project, Brianna? Yeah, Lysandra, so I saw your message that you can't get them sorted. I'll help out with that, or I'll give you a hint on Discord. But if, so there's going to be maybe somewhat of a challenge to sort your data by the top 15. That's something you have to do. So basically you need to find a way to sort the data by descending or ascending, whatever it might be. And you need to also keep track of the indices for each county. Okay, let me move this over. Jeez. Okay, so there's also a question. Okay, so there's a question, will we be able to complete the project with what we know so far? So we're going over heat maps and labeling the scatter plot today. But everything else you should know. The only tricky part is maybe that sorting thing, but you can still do that. So that you might need to look up like nope. I thought it was in my history. So sorting and I don't know what's the kind of terminology I should use here. Sorting and keeping track of indices. MATLAB. So we haven't explicitly gone over something like this, but again, I can't go over every single small thing in MATLAB. But see, I actually looked this up before, right? So you can doing something like this. So out here, it's probably kind of small. Out is basically the results for when you sorted your data by something. And then IDX here, those are the indices that are now sorted. So basically you can use something like this to keep track of the indices for when you sort it by ascending for the top 15 counties. Yeah, so do something like that, Lysandro, and then you should be good. Alright, so, but everything else we've gone over besides the heat maps and the scatter plot, but we're going over that today. Yeah, the bottom part, that's the indices. So basically, the indices were 1, 2, 3, 4 in the beginning, but then they sorted them. In this case, by default, it looks like they're sorted in ascending. So now it's going from lowest to highest for the number, and these are the indices for what they were back here. Here 8, that was the second, and now when they sorted it by ascending, you can keep track of that index. So it was the second index there, and now it's going to be the first one here. Yeah. Okay, so let's move on. So today, again, heat map and scatter plot example. We're using new data finally. So, we've used baseball data the entire semester, but I don't know, this might be our last example as a class, I'm not sure yet. But we're using IMDb data today, so download that. We're doing stuff for Breaking Bad. Yep, Breaking Bad. And so we're going to be doing that all today. And for grades, I finished grading some homeworks last night. So the only thing that isn't graded now is the project. So I've gotten started on grading that. But I won't have them all graded till probably sometime this weekend. But I'm going to get them done as soon as I can. Alright, so make sure you download this data. It's like, I don't know, 15 megs or something like that. It's still not large, but compared to the data we've been using, it's somewhat large. Extra credit. What was extra credit? I don't remember giving extra credit, but I have a bad memory, so you tell me. I gave you supplemental homework one time, but that was just for you guys. Yeah, it wasn't extra credit, it was just if you wanted more practice. Okay. Alright, so here we are. Hold on, actually give me a second here. I'm gonna change this to something else. It's too dark like this. There. Actually, wait, hold on. Yeah, okay, that's fine. Alright, so we're gonna make a new script. I think I showed you what this looked like before. Maybe I'm wrong though. But I'll show you what the graph is gonna look like. Actually, I showed you in that makeup video that I made for last Wednesday since my internet cut out. I made that makeup video. Make sure you watch that because we finished through the baseball example for the nested for loop. And then at the very end, I showed you the graphs that we were gonna make today. Okay, so we're going to be making these graphs. So we got a heat map here, which obviously you're going to be doing a lot of these on the project. So it's for Breaking Bad again, and then we have the seasons down here, and the episodes here, and what their rating was. So currently it's not going on a scale from 0 to 10. We can change it to do that, but then everything is basically red, because it's a good show. Besides Fly. I don't mind that episode, personally. Okay, and then the other graph is the scatter plot. So here we have the number of votes on this axis, and then here is the rating. So, I don't know, just another, yeah, mostly random, but it's kind of interesting too, I guess. So you have, later on, as the seasons went on, it got more popular. So there was a lot more votes, and they generally are well rated too. Anyways, the point for this exercise is to have the labels that are kind of automated for us. Okay, new script. Fly was boring, but you know, people like to argument or haven't argued that it's, you know, really like keying in on the personalities, right? Like how paranoid Walt was back then. But yeah, definitely not my favorite one, that's for sure. And I thought there was like budget issues too, because you know, they were only in the warehouse then. I don't know, I forget. Give me class. Okay. I wonder if this will work already. No. That's opening that up. That actually reminds me, okay, so quick tangent. Sometimes when you see an error message on MATLAB, you'll see like 2 different lines that they refer to. One of the lines they refer to is the line of code when the function that you're running ran into an error. So it's kind of like the script that's running in the background. And so that's the line where that script can't run. But MATLAB will also show you the line in your script when the error occurred. Okay, here we go. First thing, let's read our table. So import data. My data sheet is in a different folder, so I'm going to do it a little different than usual. So we're still going to be using read table. Let me go over this part fast just because we know what to do. Okay, so there's our table. I'm going to open it up on the left. Oh, let me do this. There we go. Okay, so we have our table. First thing that we're going to do is find how many seasons there are in this show. So if you can imagine, like, we could be doing this for many shows in this data set. There's so many, you know, there's 64,000 rows here. So there's a lot. So let's first find how many seasons there are. Basically not doing it manually. So let's actually write out code to do that. How many seasons in Breaking Bad? Alright, so we're going to say BBSN for Breaking Bad season. We're going to use our unique function. Unique. And we're going to reference our table T and do T dot season. So now we're going to be looking in this column here that's called season. So I want to find each unique season for Breaking Bad. So T dot season and then T dot series name. So that's going to be the name of the show. We're going to say find one that is equal to Breaking Bad. Alright, if I run it and I open this up, then you see that we have 1, 2, 3, 4, 5 seasons. If I really wanted to, I could also say, I could use the length command, but we actually want to reference these later on for our heat map when we have the specific season on the bottom. But if I only wanted to find, you know, as a scalar, how many numbers or how many seasons there were, I could instead put length here. Run that, and then what we get is just an answer of 5. But again, I want to have the seasons on the bottom of our heat map, so I'm going to undo this part. Alright, so let's look at this one more time. So we have our unique function, because I want to find each unique number in this column called season. And I want to find that for when our series name is equal to Breaking Bad. Again, I'm kind of using array addressing in a way for t.season and then t.series name equals Breaking Bad. Because this part here, this is going to be a logical result where we have just, you know, a 1 or a 0. And from that, I'm using those logical results as array addressing for t.season. And then we're also using unique. So we're using basically 3 different, I guess, methods kind of in one line of code here. So let's actually go down here. T.series name equals Breaking Bad. Breaking Bad. So we're going to have 64,000 zeros or ones here because I just ran that for this entire table. We could also, you know, edit this to say, we could use find, right? So find when t.series name equals Breaking Bad. Now this is giving us the actual rows, so it's from rows 1 to 62. Yep, and that's what you see there. And let's move this back down. So let me build this up a little. Let's do t.season for when t.series name equals Breaking Bad. So now we have the actual season, so that's basically going from rows 1 to, what was it, 62? And because we did t.season for when t.series name equals Breaking Bad, we're getting, you know, all of our 1s here, and then 2s and so on. But we use the unique function, so we get the unique amount of seasons in Breaking Bad. Alright, so it's kind of layered there, so maybe a bit to keep track of. And like always, if you have a question, put it in the chat if I forget to ask if there are any questions. Okay, next thing, we are going to make a string array that says season. So this is going to be in our legend later on when it's either, season 1, season 2, season 3, or whatever. I want to have this kind of be the first word that shows up. Basically, because right now it's just going to be, these numbers 1, 2, 3, 4, 5. Okay, so I want to have the string array that has 5 values, and every single value in that string array should say season. So I could do season equals season, season, and so on. Season is such a weird word now because I keep saying it. But we can use a function called repmat, and that's going to repeat whatever I put in here. So repeat, I want to repeat the word called season. And actually, we're going to put a space in here because I want this spaced out in our legend later. It's kind of like how we leave a space in our title sometimes. So then I want this to be a 5 by 1. Run that, and then let's open up season. There we go. We have 5 values that say season. You don't need to use repmat on your project, but for this example, it was useful. Okay, next thing, initializing our array. So you got to do this on the project. We're actually only going to initialize one array right now. Oh, question was, what does repmat do? So it's going to repeat whatever I put in here, however many times I tell it to. So in this case, I told it to repeat a string called season. I want to have 5 rows and then 1 column. Basically, just so I didn't have to type out season 5 times. Imagine I wanted this to be like a 50 by 50 matrix. Then I got that. That would suck to type out. Okay. Okay, so next thing, initializing our array. So this is going to be for the number of episodes that we have per season. Okay, so some of our seasons, they're not going to have as many episodes as some of the later seasons, so that's something we need to keep in mind. Let's do nep for number of episodes, and we're going to say zeros. Then we're going to have the length of BB season, so that's 5, and then comma 1. Okay, so what this is going to store, basically, right now it's zeros, of course, but here in this first row, we're going to have a number later on that says season 1 had X amount of episodes in that season. What is it, like 6 or something? It's not that much. And season 2, how many episodes were there? And then so on. Okay. Now we're going to do our first for loop here. That's smaller. Okay, so now we're actually going to find the amount of episodes per season. So we already allocated or pre-allocated the size for that array. But now let's actually find how many episodes there are per season. Find number of eps per season. Okay, so we can say for n or whatever. I could put for p for banana equals whatever. Doesn't matter. I'm going to do for n equals 1 to length of BB season. That's going to be a length of 5. Let's close it out like that. Because we want to have 5 values show up here. Okay, so for n equals 1 to the length of season, and ep, right? We're looking at the number of episodes. We already initialized that array. We want to have n rows. That's going to be 5 rows in the end, and I want 1 column, so comma 1. Okay, length of t dot episode name, t dot series name. I haven't looked at the script in a few days, so I'm going to basically type stuff out and kind of look it over. Well, I fixed a few things last night. Equals equals. I'm going to put 3 dots here so I can go on a new line. It's still going to be treating this as one line. So t.series name equals Breaking Bad. And when t.season equals n. Okay, let's first make sure this runs okay. Oops, I didn't put an end statement yet. That's why. End. Unrecognized the variable name. I put episode name. T dot episode. Sorry. T dot episode. And let's take a look at that now. So now it's showing the amount of episodes that we have per season. So yeah, season 1, only 7, then we have 13, 13, 13, and the last one, 16. Alright, so let's look at this line of code. Again, repeat myself, we already pre-allocated the size for number of episodes up here. We do that so we're more efficient. For this data size, it's not going to be a huge difference though. And then here we're finding the length. So I'm using the length command because I want to find the amount of episodes per season. Then we're looking at t.episode, so this column here, which will basically give us the episode name. And then we have t.series name equals Breaking Bad, so it's got to match this. It's got to be for Breaking Bad. And we want to look at each unique season. So when t.season equals 1, when it equals 2, when it equals 3, 4, and 5. What I'll do is break this down again, actually, why not? Let's copy and paste all of this. Paste it in there. Move this up here. So let's do t.series name equals Breaking Bad. And t.season equals, well, we can't do it for n. Let's do 1 for now. So this is going to be, again, 64,000 zeros and ones. That's not too useful right now. But at the very top here, it should be ones. Oh, maybe it probably, yeah, I can't show all of it in the command window, and there's too many rows. So let's change this to now, in the beginning here, let's do t.episode. t.episode, t.series name, Breaking Bad. Oh, I should probably spell episode correctly. Episode. And there we go. So now it's giving us directly the episode names for all of season 1. Okay, so we can see all of that right here. And you can see the episode there. And then we only want to look at the first season, right? So that's all of these rows. Okay, so we got all of that right there. And of course, we're finding the amount of episodes per season, so we use the length command. So if I then put in length here, length, then we get 7. All right, is everyone clear on this part? So a lot of this script, we're doing a lot of things in one line of code, but that'll be more efficient for us in the script, and we don't need to take up as much room too. So if you can do this in your project, and basically you can, if it's too much to take in at once, you can kind of go layer by layer like we've been doing in the command window here. And also another tip for the project, we kind of discussed it before, but if you're running into an error in your for loop, especially if you're doing a lot of calculations or you have a lot of lines in your for loop, and it might, pull an error at some point, then I would really recommend that you do what I've shown a few times, which is putting in that breakpoint. So click right here on one of these lines, which is called a breakpoint. Unsuppress your output too, so you can see what's going on. And then you can press run, and then press step so you can step through and see what's going on for your code. So what's actually happening. So I'll press step here, And then I can see that, oh, okay, it just went through our first pass. There's 7 episodes for the first season. And then I can keep stepping through, and we can keep on calculating it like that. Now this one is pretty simple, but again, if you have multiple lines in your for loop, you might encounter an error on some line in your for loop, like maybe way down towards the end. So also at that point, you can comment out different lines in your for loop, make sure one line works on every pass, and make sure 2 lines works for every pass, and then keep going like that. And one more thing when you are doing for loops too, before you actually loop, just see if you can get one value to show up. So what I showed earlier, like before we do this loop in our project, well, something like this, we can go in the command window and type out what would basically be one pass, or we can do what I just showed you by just doing one pass manually. But we can type this into our command window and see what we get and make sure that works there. Alright, so what do you mean by it kills a lot of the rest of the code? Like, you get errors then? Because I think that's what you're saying, but yeah, if you're checking like one line in your code, comment out everything in that loop besides what you're looking at, and then also comment out the rest of the code too. Alright, so next thing, we are going to pre-allocate some more arrays now, and we're gonna be using some different kind of pre-allocation methods than we've used before. For your project, I'm trying to think, so far we've been using zeros, I think pretty much all the time to pre-allocate arrays. But we can use other functions as well, so you can use like ones. And what we're going to do now is not a number and also pre-allocate a logical array. And also strings, so there's a lot going on here. So the first one we're going to pre-allocate is called BBRT for Breaking Bad ratings. So again, some seasons, they don't have as many episodes as other seasons. Okay, so season 1 is only 7 episodes, and then we have 13, and then 16. So I don't want to imply that one of those episodes has a rating of 0, because some episodes don't exist in season 1, compared to season 5. So I don't want to pretend that there was 16 episodes in season 1, and that those episodes had a rating of 0. So instead of that, we're going to put in not a number. Okay, so we're going to have BBRT. Also, we're doing this because when we make our heat map, that has to be either a matrix or a table. And when we have a matrix or a table, the amount of rows has to be equal to the, or all of the amount of rows in each column, they have to be the same. So let's do BBRT equals not a number. For our rows, we're going to have the length of BBSN for season, the amount of seasons that we have. And then for our columns, we're going to have max of number of episodes. One, two, three. There we go. Why did I still type wrong? NAN. And then we have max there. Too many input arguments for length. We have length of BB. Oh, here we go. I only want the length of that. I should have looked at this again beforehand. Okay, so here we go. We have BBRT. We have 5 rows. That's for our 5 seasons. And then we have 16 columns because season 5 had 16 episodes. And again, we need to have a matrix here for when we make our heat map. So I'm going to fill this all in with NANs because season 1 only has 7 episodes. So when I get to 8, 9, 10, 11, 12, 13, 14, 15, 16, I don't want to pretend that those episodes existed and they had a rating of 0. They don't exist, so we're going to put not a number. Next thing is BBNV for number of votes. So this will be the same thing here. Let's just copy and paste it. It's going to be 5 by 16. ratings, number of votes. Next one is going to be the episode name. So this we actually want to display the name for each episode. So for this, we're going to make this an empty string array. So to do that, we type in strings. And then this is going to be the same size as well, 5 by 16. Okay, and then ep name. And then we have the number of episodes per season. We already did that, number of episodes per season. Okay, let me delete that. Okay, interest IND. So this is going to be basically the episodes of interest that we're going to have. So, for the graph that I showed you earlier on for the scatter plot, we had some episodes that were labeled up top, and then we had like 2 on the bottom that had text labels. So this seems a little weird right now, but you'll understand what's going on here in a bit. So we're going to pre-allocate a logical array. So we're going to type in false, length, bb, sn, same thing again, and then max and ep. Indices for specified interest. Let me run it, and let me explain it to you. Suppress this. Okay, so you see here, this is a 5 by 16 logical array. So basically, we are initializing this with a value of false instead of true, because by default, I don't want to label any of the episodes. But later on, we're going to find the episodes of interest, basically, for us, if an episode is rated over 9.5, or if it's rated below 8. So I don't want to label all of them again, so I'm going to put in false. Because if I put in true, these are all going to be ones, and later on, when we use kind of array addressing, it would already be true in this logical array fashion when we use that for array addressing. So it would have a label for every single episode. Again, sounds a little weird right now, but once we get to it, it should make more sense. Okay, now let's actually start looping. So we have put loop for calculations. They're not really calculations. Okay, so let's do for I equals 1 to length of BBSN for the amount of seasons that we have. And now we're going to get the indices by season. So finding the indices again, that's often the most important part for our scripts. So like for the project and for this particular script, that's going to be the most important part. Indices by season. So we're going to do BB_IND equals find when t.series name equals Breaking Bad, and when t.season, let's do our dots again. So and t.season equals I. Run it, and then I'll explain it. BB_IND. Okay, so here we have the indices by season. So I didn't save everything here. So now I didn't do it like this, I, 1. We can actually just do I. If I do it this way, we have a 1x5 cell array for the indices by season. So season 1, that's rows 1 through 7 in our table T. We already saw that earlier, so 1 through 7, and that's season 1. Season 2 is from 8 to 20. So from 8, C2, and then to 20, season 2. But we're going to actually make our plots inside of this loop, so we don't need to save all of this data. So I'm going to delete that part. And currently, this is going to represent the indices for the 6th or the 5th season, rather. So we have find when t.series name which is going to be equal to Breaking Bad. So we want to find when that is true, and when the series or the season is equal to I. So on our first pass, it's going to say find when we have Breaking Bad, and we're in season 1. Second pass, find when we're looking at the show Breaking Bad, and we're in season 2. Right, so that's how we get our indices by season. So this is pretty standard, similar to what you've done on the first project when you found the indices for each county. All right, any questions so far? No. Okay. Yeah, I already did this. Number of episodes by season. Yeah, we did it right there. Okay, so we'll skip that part. So now we're going to go into our next loop. So this is going to be nested. So I'm going to do for j equals 1 to max of bb nep. Here we go. Okay, so for 1 to the max of nep, that's the number of episodes. So that's 16. So basically now we have this nested for loop where we have I amount of seasons, that's 5, and for j is equal to 1 to max of n episodes, that's going to be 16. And remember, we pre-allocated a lot of our arrays to be 5 by 16. So this is 5 by 16, the ratings are 5 by 16, and the number of votes, and the episode name 5 by 16. It's all of the data that we're going to have for Breaking Bad, season by season and episode by episode. All right, let's get our ratings by season, by episode. Before we go on here, does it make sense why we have this nested for loop? Because we're going by season, and for each season we're going by episode. Okay, if there's no questions or anything, I'll assume it makes sense. Yeah, so that's correct, because there's 5 seasons and the possible maximum number of episodes in a season is 16. And then if it's not 16 episodes in a season, then that corresponding cell in our matrix is going to be not a number. Yeah, you could do 2 separate for loops if you wanted, but then we would have to save all of our data here for the indices, which you can do. But we're going to do a nested for loop, which will also allow us to make all of our plots inside of this nested for loop too. Yeah, you love McDonald's, huh? So yeah, you could have 2 separate for loops though. Okay, so let's do it for the ratings now. So we're getting the ratings per episode per season. Or maybe we should think about it. We're getting the ratings per season and then per episode. Okay, so I'm going to call this BBRT. We already initialized this size before. Size. So BBRT. This time I am going to save everything. We don't need to, but that's what I did in my script, so I'm going to keep that for now. So we have I amount of rows, that's going to be 5, and then we have j amount of columns, that's going to be 16. Then we're going to look at the column called user rating. Okay, that's right here. So we're going to say when t.user rating, and now we're using array addressing. So now we need to look at those indices that we just found. So bb, ind, and this will be for j. Okay. So let's run this, make sure it works. What did I do incorrectly here? BBRT. We have 5 by 16. The answer would be I, comma j. T dot user rating, BBIND, and then j. Let me look at my script for a second. Okay, once I figure this out, this will actually also be a good time, I guess, to show you why you want to, again, look pass by pass on your loops here. And then let's see, add up here. Yeah, that's good. That's good. Okay, so let's look at this pass by pass then. Yeah, that's a J. Okay, let's do a pass by pass. And it's going to be another thing where, like for the baseball script, it's a small thing that's often the case with when you guys have questions too, when something looks exactly the same and there is a slight difference. It's always a small thing. I want to link to PPSN, our indices. Our indices. Let's comment this out. So this is like what I was talking about earlier. I'm going to comment this out because I saw there's an error. I want to look at all of the indices that we have. And this will be for the last season. Okay, now let's uncomment that. BBRT, that's 5 by 16. And we have I amount of rows, J amount of columns, T dot user rating. Shouldn't this be I comma J though? Okay, let's do pass by pass. Okay, so I'm going to uncomment that or unsuppress it. I'm going to put my breakpoint there. Click on run. And let's go to BVRT. Let's open that up. That's over here. Okay, so let's step through. Okay, so it's currently in our first row. Our first row for the first season. And now we're in our nested for loop for J. And now we're going episode by episode. Okay, so we have our first rating for the pilot, basically. And now we're going to continue to loop through here. There's a second, there's our third. Let's go all the way over here. Step, 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 step. Oh, I already maxed out on it. Why does it think there's only 7? 1, 2, max, and F. Comment this out. Get rid of the breakpoint, run that. Max of NF is 16. Okay, so it's stopping on 7 because there's only 7 episodes in our first season, but our ratings, they were pre-allocated to be NANs. So what's the issue here? T.user rating, PPIND, J. Okay, maybe it's because of this. Let's do BB and EN. I don't want to get hung up on this. So if I can't figure it out in the next minute, then we're going to move on. And then I'll tell you the issue later on. I think it might be related to this though. No, it's not. Okay, let's open up my... I'm sure it's, again, just like last time with the baseball script, it's small and it's hard to figure it out with 31 people watching. So let's open up my other script for now, just because I want to show you how to make a heat map and a scatter plot. That's the point of this lecture here. Also the looping. Okay, so it's V4. And then I'm going to comment out everything after what we're currently working on. So this is what we just typed in here. Also, you see I have like some of these commented out. This is just like for a different method using a cell array if you want. Okay, so let's comment this out. Comment that out. All of these, comment that out. And then the rest of the script, let's also comment that out. Oh, I shouldn't have done that there. No, it'll be easier if I just run it like this. Okay, let's run it. Yes, the pressure. Okay, so here we're looking at, let's go back to the line that we were looking at just a second ago, which is BBRT. So what this should have looked like in the class was like this. So let's go pass by pass again. And we can run it. So that's for our first episode in season 1. Let's continue to step through. And let's go to 7, which is where it stopped last time. So I know it's related to that. There's some issue there because, season 1 has 7 episodes, and that's it. And on the script that we were just working on, basically it thinks, or it stopped after 7 because there aren't more than 7 episodes in season 1. So there's something up in my script up here, in the past script we were working on, where there's some issue related to that. But what should occur is we go to column 7 and row 1. Okay, so we get that rating, and now for the rest of it, that should stay as not a number. Okay, it's doing this because it's working on our figure there. So it starts to put stuff in. Okay, see, and then there's our second season, and in season 1, all of these are still not a number. All right. So that's what should have occurred. Again, I'll go over it and put in Discord what was wrong, or send out an email, because not everyone is in Discord. But in the meantime, we'll just look at this script. Okay, so that's the ratings. Go back up here. So what we did was we looked at t.user rating, which is here, and then we used our array addressing here, pass by pass for each season, and then we have the j amount of rows, which is the maximum number of episodes per season. So that was 16, and that allows us to get the ratings by season, by episode. All right, and then we continue doing that same, or using that same logic to look at the user votes and then the episode name. So let's go back to the table. We also have a column called user votes. And then we, of course, have a column called episode right here, and that's the episode name. So we're using exactly the same kind of array addressing there to get all of those values. Also, something of note up here for our indices, we used find, and we used find for a reason. So that gave us the indices straight up. But if we do t.series name equals Breaking Bad, whatever, that's going to be a logical result there. Now it's going to give us an issue because it's looking at all of the rows in our table still, 64,000 rows in the table. And it's trying to apply that in our script here. But we actually just want to look at the indices that we found for each season, which had a maximum amount of values of 16 episodes. Just here, let's continue to put in find, and then the script runs okay. All right, so we have the ratings, we have the number of votes, and we have the episode name. Now we're going to talk about that area of interest that we mentioned earlier. So in our scatter plot, all of these episodes up here, they're of interest to us where we want to have a text label. And then all of these down here, we want to have a text label too. So basically what I did was I said, if the rating is over 9.5, or if the rating is below 8, then those are episodes of interest. I want to have a text label for those. Okay, so inside of our nested for loop, we're going to have an if statement. Okay, so this is going to say if bb underscore rt, so if that rating for any of the cells in there, so it's going to look through all of the rows and all of the columns, if anything in here is greater than 9.5, or if that rating is, or if there's a rating that's less than 8. So not and, it's saying if we have anything that's over 9.5 or anything that's less than 8, then let's collect those values. Or let's say that it's true, really. So interest ID, remember we initialized that as a logical array of falses. But now I want to fill in the corresponding values for when that was true. So here we see one. This is basically season 4 and then episode 3. So season 4 and episode 3. Season 4 and then episode 3 right here. That was called Open House. And that rating, I think that was a bad rating. 7.9. Okay, so that's less than 8, which is what we said. So there's a logical 1 for that value. Okay, so that's one of interest. So basically, we have interest ID equals when we looked at stuff when it was greater than 9.5 or when it was less than 8. Okay, and then here we are actually building up that array, that logical array, for when the number of votes is basically not equal to 0. So basically this is, again, this not equals 0. This is just for our logical kind of indexing. So then we can collect all of those logical results and where'd it go? Interest IND. Okay, and then I can actually change this to, I think if I remember correctly, I can change this to just ratings, because basically I just wanted it to be for the size. And yeah, we can. So I just put NV or RT just because that's a 5 by 16. And in the beginning, all of these, they weren't equal to 0. Okay, so we have all of those now. Let's go back here. There we are. So now we have these logical results of 1s, and we actually want those to show up in the graph. Absolute value sign, I think that's just ABS. Let's do doc ABS. Yeah, that's absolute value. Okay, so we have all of those, and then now we can use array addressing later on for the legend for that. So basically what we would want to do is do app name, and then use those logical results as a way for array addressing. So interest IND, and these are all of the episodes that we're going to have in our legend, or sorry, not in our legend, but for our text labels on the scatter plot. Okay, so all of these are episodes that were either above a rating of 9 or lower, or sorry, 9.5 or lower than a rating of 8. Okay, offsets. So these offsets, basically, they give us the amount of space that we have in the x direction. So that's dx, and then dy is going to be the amount of space that's offset from our scatter plot points in the y direction. So by default, the text is going to be basically overlaid on those scatter plots. So let's comment these out. Oh, well, I have dx in there, so let's change this. So I'm going to change this to 0 and 0. Or just do 0.01, just so we have some value in there. And see, by default, it's kind of overlaying these scatter plots, or these points. So it's good to have a little bit of an offset. And what I personally recommend is doing something like this. So for my x offset, I'm doing the maximum value for our table for the number of votes, and then I'm offsetting that basically by a percentage. And same thing for the ratings. I'm looking at the maximum value, and then I'm going to offset that by a percentage as well, just so everything is consistent across our graph for the offsets. All right. And that's actually more important for if this was on a log scale. I even made this graph on a log scale one time, just because there's so many number of votes here, but it doesn't really help that much. Okay, so next thing, actually making the plots, which is the most important part of this lecture, and we only have about 15 minutes left. Let's go over that. So the first one is going to be the scatter plot. So making a scatter plot is simple enough. I think we've gone over it before. The thing we want to look at is more the text labels. But we're making both of our figures here. So I'm assigning this to a variable of h. You don't need to do that, but down here, I'm telling it position the size of it and then visible on or off. Okay, so we're doing our scatter plot. I want to do this for our x data. That's going to be the number of votes that we have. And then I want to look at all of the rows that we have. Don't have that open. PBNV. So all of the rows that we have, I want to loop through those. And then for each of those rows or each season, I want to put in all of the values that we have for the number of votes. And same thing for the ratings. I want to loop through season by season and then put in all of those values for the ratings. Then we use the filled argument so it actually looks nice. I mean, look at this by default. I don't like it. So you don't have to use filled on your project, but I think it looks better. Okay, and then we say hold on because I want to continue to plot season by season. If I don't have hold on in here, all we're going to have is the last season. So if this is the last one, it says season 1, really it's the last season though. Okay, so let's put back and hold on. Then again here, this is just going to set the size of the figure and then whether it's on or off. So we're going to leave that as on. Okay, these mean values, so on our plot we have some dashed lines. And these dashed lines, as you can see in the legend, they're going to represent the average. So this is the average amount of votes per episode, and then the average rating per episode. So to do that, we used an X line and a Y line. So for X line, that's going to make a vertical line along the X axis, in this case, for the average amount of votes per episode. And then down here, Y line, that's going to be the average amount, or the average rating per episode. And you can kind of go through this by yourself, but we're running out of time. But if we have time at the end, I'll go through all of what basically all of this means. But it's getting, first it's doing the average per season, and then it's getting the average by episode. But if we have time again, I'll go over that. And over here, K dash, that's to have a black dashed line. And then handle visibility, I can change whether this shows up in the legend or not. So if both of these were set to on, then we're going to have two dashed lines. Well, actually later on, I guess I changed that. But by default, it should be two dashed lines. But I did something else in my code to have a text entry in that legend for the dashed line. But I don't want to have both of them show up, so I can put one of them to off. I guess in this case, I could have had them both on. But you'll see later on for my legend, I added an entry right there, which, or right here, which you'll see. Okay, X label, Y label, easy enough. Getting the current axis properties for this figure. So remember earlier on, I said H equals figure. So to now access the properties for this figure, or the axis properties, we have to use this kind of format. So AX, instead of doing GCA, I have to type in h.currentAxes. That'll allow me to get rid of the exponents. And then here we go, the text labels. So the format for text is to put in all of the X data, so all of the locations for the number of votes. And then we supply the Y data, so that'll be the ratings by episode. And then the very last argument that we have is the actual text label that we want to have, which in this case is going to be the actual episode name for those episodes of interest. So remember, some of these have ones. Those are the episodes of interest that we have. And we use this logical result as a way of doing array addressing to get those labels. So BBNV, interest IND, we can take a look at that. Okay, so this is going to correspond to the number of votes for those specific episodes of interest. So that'll get our X location. And then our Y location is the same kind of thing, but we're getting the rating for those episodes of interest. So that allows us to get that X location and that Y location for those episodes that we want to have labels for. So it gets the locations for all of these and these two down here. And that very last argument, we actually put in the text label that we want to have, which again is going to be the episode name. And you see I also have plus dx and plus dy. Those are the offsets that we talked about earlier. If I don't have them in there, then our text labels are going to be overlapping with the scatter plot. Okay, any questions on this part? Want to make sure we get to our heat map here. Oh yeah, I'll talk about the legend too. Alright, so for legend, our first 5 values in this legend are going to be for our first 5 seasons. So remember, we made a string array earlier on called season, and all of this was a string array that continuously says season. And I want to add on to this a string, so we have to use num to string, where that's going to display the actual number for that season. So that's 1, 2, 3, 4, and 5. And then we add on, so we put a semicolon here to basically put another row in our legend, and that's going to say average. And that is going to correspond to that black dashed line that we saw earlier on. And then we just specify the location as well. And then I turned on a grid for that figure. Alright, so for the heat map, this is, maybe the more important one for the project, because we have more of these. So heat map, again, it has to be either a table or a matrix. I'm pretty sure it can't be a cell array. I can't remember off the top of my head. I'll look that up if we have time. I'm pretty sure it can't be a cell array, so it has to either be a matrix or a table, because again, the number of rows in each column, they have to be the same. A cell array, they don't have to be the same. But for a heat map, we're basically plotting a matrix for the heat map. So the type in MATLAB either has to be a matrix or a table. So our first argument for heat map, that's going to be whatever we want to have show up on the left-hand side. Let me turn this graph off. Okay, so on the left-hand side, I want to have all of these episodes show up. So that's 1 through 16. So that's BBSN. I'll type that in the command window. Or sorry, I'm looking at the y-axis. We're looking at the x-axis here. So that's going to be the seasons that we have, right? We have 5 seasons. I want that to show on the x-axis here. So that's what we put in for our first argument. Basically the x label, in a way. Really, this is our x label. That's a season. But what we want to show up on our heat map along this axis is the specific season that we're in. Okay, then the next one is going to be what we want to show up on the y-axis here. So I want to show, episode 1 through 16. So what I essentially made here was a column vector, really just some vector. So 1 to max of nep, that's going to be 1 to 16. Here, this will show up as a row vector. And you see that's from 1 to 16. And we're supplying, don't think of it like a row vector or a column vector. We're just supplying a vector for our y argument. And again, that's going to be a vector for numbers 1 through 16 right here. Then the last argument is going to be what we actually want to be plotted in our heat map. So for us, that's going to be the ratings by episode and by season. So you see that I also transposed this. So let's type in size of BBRT transpose. And you see that's a 16 by 5. And then let's type in size of BBSN and size of 1 to, maybe I should have made that some variable before. Size 1 to max. And actually that part doesn't matter. Let's just type in BB, size of BBSN. So that's a 5 by 1. So you'll see here that this has 5 rows, and up here this has 5 columns. So these values, they have to be the same when we make a heat map. So if it's not the same, and I try to run this, then you see here that we get an error, right? It says the number of x values must equal the number of columns in color data. Color data, that's basically what we're plotting for our heat map. In this case, that's the ratings that we have. So if I have 5 seasons, then I need to have basically 5 columns here for our data, which is what you see here. Currently, this says that I have 16 columns. That doesn't match up with the number of seasons that we have. Okay, so that's why we transpose it. And then the number of seasons that we have matches up with the number of columns that we have for the ratings that we're plotting here. All right, does that part make sense? Because that will most likely show up for many of you in the project. Not because you don't understand it or didn't think about it, but that might pop up and you need to make sure that you understand the error message itself. Didn't mean to close out of that. Let's minimize that. Okay. I will take the silence as you understand it, hopefully. But again, I'll repeat it one more time. So let's go back down here. Let's go in our command window. Let's type in, I guess really I should do length of BBSN. That's 5. So because our X data, that has a length of 5, then MATLAB is telling us that our heat map, that the number of columns in our heat map has to match the length for the X data that we supplied. So the length for our X data, that's 5, because we have 5 seasons for Breaking Bad. So the number of columns that we have for what we're plotting in our heat map, that also better be 5. So size of BBRT transposed, that's 5. So because of that, we're good. And then we can make our plot. Okay, last thing over here is color map. So you don't need to use a color map by to make a heat map. I think by default it's blue. Yeah, so by default it's blue. That's boring. Doesn't really show the variance that we have too well. So we can use a color map. And the one I used, was it Turbo? Yeah. Okay, and there's other ones, you know, you could do like summer is one. You can look them up. So just type in like MATLAB color map. And you can see all the color maps that they have. And then I think on the project I used Turbo as well. Just because that's good at showing like cool colors means low, high colors, or warm colors means high. Alright, so here I'm accessing the properties for a heat map. So you see right here, I typed in k equals heat map. That's going to assign a variable to our heat map. And from that variable, I can access the properties for our heat map. No, okay, that's not k.properties. Nope. Okay. There we go. So I typed in k, and then I looked at all of the properties. So these are all of the properties for our heat map. There's a ton of stuff in here. And by default, our missing color data, let's plot this, is black. This looks, I mean, if you like it, you like it. I think it looks pretty offsetting. So what I did is I changed this to be white. And you won't have to do this on your project because we have the same amount of, like here, these would all be the same basically for your heat maps on the project. So, but basically, you know, all of these white cells, they are not a number. And so that's missing data. So I'm telling MATLAB, make that missing data a color of white. So the scale for our color bar over here, currently it's starting at whatever the lowest rating episode was, which is 7.6. That was Fly. We can change that to instead start from 0 by using the function called c-axis. So if I want to make it from 0 to 10, we can do that. And then you see like everything is red because again, it's a good show. But this might be a good idea if you were making a heat map for, a ton of shows at once. Thinking of Game of Thrones for the last few seasons, absolute ass. So maybe this would be a good idea to have it from 0 to 10 if you're comparing a lot of shows at once that have a very big variance. Okay, labels, you know how to do that, X label and Y label. Title, and then again, this last thing is just setting the size and making it visible or not visible. Okay, and then there's one more thing which I forgot to mention, which is whether or not we want to display values in our cells. So by default, that is on, but also at a certain size, they turn off. I need to make it smaller actually. Or maybe actually they're gonna stay here because they're already set. But if we had this output to a smaller size, they might turn off. So on the project, you can do either or on the project if it looks okay. But again, by default, it's going to show the value for that cell. In this case, it's the rating. Now there is a way to turn it off. And I forget off the top of my head, so let's type in doc of Heatmap. I know we're running out of time here. Let's see if I can find it. The documentation is good, so definitely take a look at it if you don't know how to do something. The labels, so there should be, go to see data. Okay, we could probably just say, like, make that just empty. Like empty brackets that we do sometimes. Actually, no, that's what we're plotting. So I know there is a way, because I did it on the project. I probably just Google it. MATLAB, Heatmap, remove labels on cells, something like that. Should come up. Oh, there you go. See, I looked it up one time. I think this is for something else. So cell label color and then none. Okay. So for that, we probably need an axis, K. You can leave if you want now, if you need to go. I just want to see if this shows up for our properties. So K, show properties. And then, let's see, what was that called? Cell. Oh wait, no, that's for the label color. Never mind, that's for what we talked about before. Okay. Something to do with our label format here. Anyways, there is a method. You can do it, but by default for our project, I think all of them besides one figure aren't going to have the numbers because they're too close together. So the one where it's for manufacturers by county on the very last day, that will have labels on it, but you can change it to not have these labels. I can't find it right away, but it'll be easy to look up. I'm sure I could find it in 2 minutes instead. So you can look that up if you want them or not. I won't mark you down if you have these text labels or not on the project. Either way is fine, as long as it looks good and it's not like super jumbled up. All right, so that's it for today. We're out of time. I will again find out the issue I had in that script, and I'll make, I guess, a video or something for that. This wasn't as in-depth as I would have liked for this lecture, so if you have any questions, then let me know, but if not, that's it for today, and then we'll go over something new on Wednesday. I'm not sure if we might go over the first project on Wednesday. I'll go over the code for that. If not Wednesday, then next Monday. So anyways, that's it for today though. I'll see you guys on Wednesday. Make sure you start working on the project too.
Thank you. I had a question. So you're gonna post a video about going a little more in depth on this code?
Maybe I want to, but I don't know when that'll be because this week is busy since I have a midterm. But at the very least, I'll go over whatever the issue was that I had earlier on.
Okay.
But I would like to make a more detailed video.
Okay. And when are you gonna go over that little detail you had with the code?
What, like the issue I had, or
the little issue.
Yeah. If I don't make a video, I'll talk about it for sure at the beginning of class on Wednesday.
Okay. Thank you.
Mm-hmm.
Have a nice day.
Thanks, you too.
I have a quick question, Professor.
Okay.
I was wondering if there were multiple shows other than just Breaking Bad and we wanted to see them for each season, would we just create more unique codes? Like where it says the T series name equals Breaking Bad?
Like right here?
Yeah.
Yeah, if you want to for a different show, you could just do it like that. Or, theoretically, we could loop through that entire data set and create this data for each show. You could do that too. So you would need to basically have more loops, which might be an interesting video to make too. Yeah, you could do that.
Oh, sorry. Would I be able to do that then on the project for each the top 15 most vaccinated counties?
Well, what do you mean?
Like, so instead of it being like, how would I say this? Let me see really quick. So for like the percentage of the fully vaccinated, percentage of population fully vaccinated and sorted by the top 15 counties, I can just reorganize it where I have like the cumulative total doses within the counties.
Yeah, so what I did for that is I had a loop that, got the data for every single county. I think in the beginning it's sorted alphabetically by default. So it gets the data for every county if we're talking about like percentage vaccinated. And then from that, then you can sort the data. Like we talked about in the very beginning of class, you can sort that data and you can keep track of the indices for those counties. And then you can do it that way. So you don't even need a loop. You just need to sort your data by like ascending.
Okay, or descending, or is it better to do? Because I did it by descending for the top.
Oh yeah, descending. That's right.
Okay, so that's what I did for like the cumulative doses, and then I decided to do the unique where I do the table and then the dot cumulative total doses, and then I was gonna do the dot counties, and then
Okay, so you're trying to find the cumulative doses as of like the last day by county?
Yeah.
Okay, yeah, so for that, I would just use array addressing like you did in the first project. If you found the indices for each county, just grab that very last, or use array addressing for that very last row in each county. And then if you have to sort it, you can also sort that by descending to, and then you can also get those indices when you sort it at the same time, like I showed in the very beginning of class. So that's a lot of stuff like together, but you can do it that way.
Okay. So there's multiple ways to go about it then?
Oh yeah, definitely, yeah. I think that's what I did when I worked on the script, but yeah, there's a lot of ways to do, basically everything that we go over in class, there's a lot of ways.
Okay, just making sure.
Yeah, you can use whatever method you want as long as it works in the end and you're not hard coding.
Okay, then if I have any more questions, can I just send you my codes over Discord?
Yeah.
Okay, thank you, Professor. Have a good one.
Thanks, you too. All right, anyone else?